Now, you cannot construct a linear combination of spin orbital products where you assign 2 electrons to the same spin orbital. What happens if you assign 2 electrons to the same spin orbital with your Slater determinant? What would happen is this. Okay? Remember, each of the terms that you get when you expand your spin orbital would be something that spin orbital that depends on electron 1 times a spin orbital that depends on electron 2 times a spin orbital that depends on electron 3. So you, if you're going to assign 2 electrons to the same spin orbital, basically what you're saying is you're making 2 of these columns the same. So you might have, in order for you to be able to have, for example, electron 1 and electron 2 assigned to spin orbital F1, then you're going to have an F1 of 1 and F1 of 2. So this column would all be F1s. And anytime you have 2 identical columns in your determinant, that determinant is equal to 0. Okay, let's verify that. That's one of the properties of a determinant. Anytime you have 2 columns or 2 rows that are identical, that determinant is going to be equal to 0. Let's see. Let's try a 3 by 3 determinant, for example. Okay. So let me write a determinant here. Let's try 3 by 3. Okay. Let's say I want to do 1, 2, 6, 5.6. Okay. And 1, 2, let's say 3. Okay, I want to make 2 columns identical, so let's make this 1, and that's also a 1. And that's a 3, let's say this is 7.9. And let's make this 2.8. So if I want to make these 2 columns identical, the first 2 columns, I would have to make this one also 2.8. Pick a number here. 30. Okay. That's 0. Anytime you have 2 columns of any 2 columns of your determinant, if they're the same, then you get the determinant is 0. So that would not be an acceptable function because we don't want our side to be just 0 everywhere, right? So again, setting it up as a Slater determinant, you cannot have more than 1 electron assigned to the same spin orbital. That's another way of saying that if you assign 2 electrons to the same orbital, they have to have different spins. Okay, remember, when we say spin orbital, we're specifying not just the orbital, but the spin. So that is known as Pauli's exclusion principle. Okay, so Pauli's principle says the wave function must be antisymmetric with respect to exchange of labels for any pair of electrons. Pauli's exclusion principle says that you cannot assign more than 1 electron to a spin orbital. Okay? Or you cannot assign more than 2 electrons to an orbital, and if you do, one has to be spin up, the other one has to be spin down. Okay? So if 2 electrons are in the same orbital, they must have opposite spins. So that's known as Pauli's exclusion principle. Another way this could be phrased, you've seen this in your freshman chemistry, is that no 2 electrons can have the same set of 4 quantum numbers. So in other words, when we specify n, l, and m, quantum numbers n, l, and m, we are specifying the orbital that we are assigning the electron to, right? And by specifying m sub s, we're specifying the orbital and the spin. Or we say we're specifying the spin orbital for the electron that we're assigning the electron to. So, consequences, how many electrons can you assign to an s orbital? 2, okay? 1 spin up, the other 1 spin down. How about a p orbital? How many electrons can you assign to a p orbital? Also 2. Any orbital, okay? Any orbital, remember, an orbital is specified by specifying n, l, and m. And for a given n, l, and m, for any orbital, your m sub s can only be +1/2 or -1/2. So the answer there is 2. How about a d orbital? 2. You see this spin up or spin down. Okay? So for any orbital, there's only 2 ways you can assign an electron. So there's only 2 electrons that can be assigned to that orbital. And 1 electron must be spin up, the other one must be spin down if you have 2 assigned to a particular orbital. Now, how many electrons can be assigned to an s subshell? 2, because an s subshell is just the s orbital, right? What about a p subshell? P subshell has 3 orbitals, right? M equals +1, 0, or -1. Or you can say px, py, and pz, right? So there's 3 orbitals in a p subshell. So for each orbital, you can assign 2 electrons. 2 times 2 plus 2 plus 2, or 2 times 3. That's 6 electrons that you can assign to a p subshell. All right? So be sure to make that distinction. 2 orbitals for 2 electrons maximum per orbital, whether it's s, p, d, f, or whatever. But for a subshell, well, it depends on how many orbitals you have in a subshell. How about a d subshell? How many electrons can you assign to it? A d subshell consists of 5 orbitals, right? So times 2 electrons per orbital. So that will give you 10 maximum number of electrons that you can assign to a d subshell.